All right. Thank you all for listening and joining. My name is Shaun McCullough, and I'm really excited because I love this idea that we can write code or configuration files or something like that, and we can create infrastructure from it. I'm a software engineer, been doing that for, 25, 30 years, I guess now. But on the last 10 years, I've been really focused on infrastructure and infrastructure security and IT security on different ways of doing it. And being able to meld those two things together is just so cool and so much fun. So in this talk today, we're going to talk about infrastructure as code, how you can use it. I'll give a little bit of a history on it, and we need to talk about why it's important, why we think it might be helpful in your organization. And then we'll talk about how it can be implemented, some really great use cases, and then we're going to do a demo, or I'm going to do a demo, and the demo is really going to be focused on AWS and how we can take cloud and infrastructure as code and meld it together. And then at the end, I have some time for questions. We'll take a couple questions. So let's hit it. I'll tell you, I don't know, it was over a decade ago, I was working as a manager running an IT engineering team. And the folks in that team were just brilliant. They were building and creating and deploying and operating really complex infrastructures for different customers. And when I think about them and how they would operate, how they would work, and how they would plan, to me, they really look like this: artisans. They were craftsmen. They were taking and building an infrastructure by hand that they were using years and years of experience in order to be able to create this thing. And I got this picture here of someone who is hand making a, well, actually, I don't know what it is, but it looks really nice, doesn't it? It's some kind of wooden thing, a bowl or something. But, you know, when I look at what this person is doing, I have to imagine they've spent years honing their craft. And when they sat down to make this design here, they probably had a blueprint that they sketched out, and they kind of drew out like what the design was going to look like. But you know, they're not using that right now, right? I mean, they're taking their years of experience and they're handcrafting and they're cutting it. And every time they cut it, they're feeling it and they're saying, okay, that feels right because I have the experience. Building and running infrastructure feels like this. We build this really complex thing, and we'll have people on there that are running it, that have been doing it for years, and they make changes. And as they go, they make changes and they update and they change and craft, and it gets past the blueprint. But that's fine because they're creating the infrastructure that we need. And so I look at it with the kind of people that do this, these artisans that create this one-of-a-kind infrastructure. They spent years, you know, Frank has been running this infrastructure, for this company for years, and he knows everything about it. You couldn't just say, hey, go build a second one, right? I mean, that's really hard to do. It's a one-of-a-kind infrastructure. When you build these one-of-a-kind infrastructures, it really does become hard to track changes. At one point in my career, I was working with a blue team, or like a team that would go in and do an analysis of an organization. They would tell you everything that you could do to improve it. And it was always great walking in and saying, okay, well, the first thing we're going to do is we're going to build you a network map. And like the customer, like that was the thing they were most excited about, because they actually did not have a network map. And they're like, okay, great. You know, I don't care about the vulnerability assessment, whatever. But they really like that network map because it was hard to track the changes as the years go on. And it's also kind of gets hard to alter the design. You might want to make a change, and you have to go talk to a bunch of people. And once you make the change, it takes hours to do. And if it works, it works. If it doesn't, you got to spend more hours even rolling it back. This is how I see how we run infrastructure today, how we build data centers with all of our virtual machines, our hardware, and our databases, and our monitoring systems, and all. It's like this. It's handmade. I have a vision. I believe that we could do this differently. I really believe we can make it look more like this. The video may not be coming through GoToMeeting too well, but this is a 3D printer, right? So this is a 3D printer creating a really weird red hand. I guess. I'm not really sure why, but anyways, that was the video. So, and you think about this 3D printer and how it works. Somebody spent a ton of time coming up with a blueprint for this hand. Everything about this hand was designed. But once all that design work's done, they just feed it into the 3D printer, and out comes the other end is a hand, right? I mean, that's pretty neat. What happens if you want to build a second hand? How hard is it? You just click the button, right? So you push the button, there's a new hand's being built. It's awesome. What if you realize that you don't like the hand? You know, it's kind of like this. Maybe you want the thumb to be out or whatever. You just throw this hand away. The time and the energy is not in the creating of the hand, it's in the blueprint. So you go and you make changes to the blueprint, you push the button again, and out come the other end comes another hand. I feel like we should approach infrastructure like this. I believe that what we should do is focus on blueprints and then have that blueprint, run it through a machine of some kind, and that machine at the other end is infrastructure. I believe that's what we should be able to do. And so infrastructure is code married with some other technologies. I see that we can do this. So a couple of things with this design and with my vision of how I think infrastructure should be, we could recreate multiple hands or multiple infrastructures or copies of it because all the time was put into the blueprints. There's relatively little cost in just creating it. Although if you've run a really large cloud infrastructure, there's a lot of cost there, but I hope you get my meaning. What's great about software design is over the decades in which people have been building it, there is this really awesome software development practices and best practices and tooling that comes with it for how to check and code and test code and comment code and just everything about code. And we can take those and apply them to the blueprints of our infrastructure. So that's another really benefit. And then what is really great about it is that we can do constant iteration. I can do the hand like this and then the thumb in and then whatever. It's constant iteration. You can throw away the design, you can have it build a new one. The blueprint is what is the most important thing and not really the product itself that can be changed. So I see as infrastructure as code looking like that. Now, before we talk about infrastructure code too much, I got to tell you about kind of how I feel like we've got started in this area, and it was really through this idea of DevOps. And I've got on the screen that you can see a definition, but the best way for me to describe DevOps is to tell you a story. Back in the late 90s, I was working at a company and we built web applications for like Fortune 100 companies. And it was very customized, crafted for a particular company. And it was one of these places where if the client called and said, hey, I want my web page to be all red with yellow buttons, we would say, okay, and we would make a web page that's all red with yellow buttons, which we did. It was a terrible website, but they paid us, they liked it, whatever. But it was just kind of this QRC thing. We would put out new versions of code every 6 weeks. We were pretty fast. We thought we were awesome. Just to give you an idea how old I am, the stuff we were building, the front end was Cold Fusion. Yeah, Cold Fusion. We were one of the first places to actually use Cold Fusion before it was named Cold Fusion. The back end was Sybase. So if you've used Sybase, I'm sorry. If you have never heard of Sybase, just know that we were super excited when we got Oracle. So it was when we went from Sybase to Oracle, was awesome. So that can tell you how bad Sybase was. Anyways, so here's the point of the story. We were one time, if you've ever run infrastructure and you've ever done deployments of applications, the worst time to do a deployment of a major upgrade is on Friday, right? I mean, that's the worst time. So one Friday afternoon, we're doing a deployment, and we get this. We go and we do the deployment, and our database administrator, his name was Ralph, and Ralph went and checked everything, and he says, okay, I've deployed the upgrades. I'm going. I've got something to do down the street. So he went to a happy hour with his friends or something down the street. So we were left to test. And I think it was about an hour and a half, maybe 2 hours into it, somebody came running into my office and they said, half the site is broken. It's like, oh, okay, I'll take a look at it. Of course, it was all my stuff. My stuff was all broken. What she found was that when she goes to do certain things, there was database errors. I was like, oh, it's Ralph's fault. So I called Ralph and I said, Ralph, I need some help. Something's wrong with the database. So he walked up from the happy hour, sat down, figured it out in 15 minutes and left. And the problem is that we were using this Sybase and all the developers, we were all using version, I don't know, 3. I don't remember the version number, but we were all using this version of Sybase, and the developers were using the dev version, and Ralph had deployed the production version, and the really only difference was he had things like backups and stuff he could do. But we found out that actually the dev version was okay if you would use single quotes or double quotes in your strings, but the production version did not like the double quotes. And so all of my stuff had double quotes, it just died. So we fixed it, and it was kind of a panic, but it wasn't too bad. But the outcome of it was we decided that instead of going from development to production and just Ralph taking and deploying it, we're good, we would create an integration environment. So we would create this other environment, and in this environment, Ralph had an exact copy of all his stuff. Everything in production is now in this integration environment. And so when our stuff goes from development, it goes to integration for a couple weeks, and they test it. And then it goes from there into production. So 2-week delay now. But also we had to add like a configuration control board, because if Ralph made changes to production, it had to go to integration, and it was all this coordination. And what we did is we took our QRC that we went from development to production fairly quickly, and we spread it out. We made it too long. DevOps is the goal, is to try and get those things back together so that they are as close to each other as possible. And so it is a set of software development practices and tooling and processes that says, can we get developers and operations closer together? And the best way to do that is to be able to describe your deployment in some kind of configuration or code. So from DevOps, and I'll hit some DevOps tools in a minute, but from DevOps, we went into this idea that, okay, if I have DevOps, maybe I can do something even more with infrastructure code. Even in the old DevOps days before cloud, we were trying to make this infrastructure be malleable, is what we want to do. We want to make it adaptable. So as I described earlier with the hand, if we decide our infrastructure, we have this hand and the thumb is out, we want to make it end, can I make a change to my code and have it deployed? So it's malleable, it's changeable, I can always change it. I can always describe those changes. Can I make it fault resistant? Oh, that's a big one. If something goes down, I don't actually have to have a human go and figure out how to rebuild it. It's already in code, I can just rerun it. Maybe the engine will build it if something failed. That makes it recoverable. We want to be able to create this idea of continuous integration. So with DevOps trying to get development and production together, this idea came out with continuous integration and continuous development, which stated, hey, I can actually move from the development team into a deployable product multiple times a day. You look at the big companies like Netflix or Facebook, they're deploying hundreds of times a day. And then I can also create gates for our infrastructure changes. So before, you would have people and they would go and update a server, and the way to track those changes was usually manual. Somebody had to say, here's a ticket, and you responded to the ticket. But if you use infrastructure as code, you're describing the infrastructure in a file or a set of files. You can check that into a code repository. You can have gates to test it and monitor it. All the things that we do with continuous integration, we can do that with infrastructure as code. All right, so just some tooling around this infrastructure as code. And actually, DevOps kind of really started when the virtual machines started becoming prevalent in our deployments. Virtualization allowed us to take the entire operating system and describe it in a way that it was a file. Like if you've ever, virtual machine is really just a set of files, like really big files, but they're still files. And it made them kind of portable, more portable than the physical hardware, of course. But I could take this virtual machine and I could load it onto a thumb drive and take it to somewhere else. The other thing is that products like HashiCorp or companies like HashiCorp built something called Vagrant, and Vagrant was really designed to help that DevOps environment to say, hey, I want to be able to describe in a configuration file how to deploy this virtual machine with things like memory and the size and maybe networking, and also this is what you use for deploying the virtual machine, or maybe this is the core piece of code that you're going to use to deploy it. And Vagrant makes that easy to deploy different kinds of virtual machines, different kind of virtual machine products using this description of code. The nice thing you can do is at runtime or at deploy time, I guess, you can configure how you want that deployed. So you can have this environment set up where you say, hey, in development, I only want a small virtual machine, but in production, I want it to be a big one. But you can have all that listed in the same code so that as a person says, all right, what am I deploying? They understand each of the deployment environments and they understand how to deploy it. So Vagrant is a product that HashiCorp has. Lots of people really love the tooling that HashiCorp creates. I do like it. I actually, for my master's program, I did a research project on using Vagrant to deploy virtual machines for pen test labs. I had a hard time getting the networking to work with the Vagrant for whatever reason, but that's probably just me. But HashiCorp is really one of the premiers for doing that. But that only describes the operating system in the physical virtual machine. It doesn't describe what's running in that virtual machine. So we have these things called host configuration systems. These install packages or software, configuration files, or manage users, or whatever it is you're doing on the operating system to get it to run the apps you want to run. And they're designed to be managed across a fleet of very similar systems. Hopefully, if you have a whole bunch of web servers in your environment, like you're saying, okay, all of my web servers are Nginx and with a certain version. So if I need to update them to the next version, I may have 100 of these. I could do that all from one location and deploy it as a fleet. That's the idea for some of these tools. You can use parameters, some coding, environmental specific information to deploy differently. So you can say, this is my Nginx for production versus testing, or even better, this is my Nginx deployment for marketing versus for the billing team, right? That might look a little bit different. You can describe those in these tools. And the idea is that for these host configuration that I have down there is you can use them across your on-prem environment and in your cloud environment at the same time. Ansible is actually, out of these, Ansible, Docker, the products that I've used. Ansible's great. It's written in for Python. And this idea is you have this control system and you go out and you can describe how you want to implement things and it will go out and implement them. Chef is another product, and Puppet's really great for like large, complex environments. Ansible, I think, is probably the easiest to get started. I put Docker in here. Docker is not like Puppet or Chef. It really isn't. It's different, but that's okay because we use Docker in a very similar way as we might use the other tools to be able to create a repeatable application environment that you can use over and over again. So I put it in here. It's not quite the same thing, but it has a very similar purpose, at least in the context of this talk. They're great. Virtual machine is great. Ansible is great, but they only do things in the virtual machine, right? The virtual machine on the host, that's kind of where their focus is. With cloud, with especially infrastructure clouds like Google and Amazon and Azure, those kind of products, they really can take it to the next level because you can not only describe a virtual machine in its memory and size and things like that. You can describe not just what gets deployed on that virtual machine, but you can describe the entire networking environment. You can describe your DNS deployments. You can describe your firewalls. All that stuff is describable because the cloud environments create an API that lets you interact with everything. And so when we had this back in the day when we were deploying virtual machines, and I said, oh, there's this virtual machine and it's movable and I can package it up. I could do stuff inside that virtual machine, but it was really related to that virtual machine. I can now do everything in a data center. Maybe if I can replicate a data center in the cloud environment, and I can describe all of those through an API. Networking, host, security. Security is a big one. The clouds are designed to be self-service, so you can go and do all this stuff as long as you give them your credit card or the company credit card, right? Not your personal one, hopefully. But you're able to go and you interact with these things. It's also automatable, so you don't have to go and request a resource and wait for somebody to give it to you. It's all automated, all self-service. It's all there. And within the cloud environment, there's a level of standardization. We can quibble over how much standardization, but if you're going to build Amazon infrastructure, it kind of all feels the same for doing that. Same with Azure. It kind of feels the same for doing it. So deploying a virtual machine and deploying a blob data store have kind of the same interactions. There's also tooling that's been created to support that interaction with the API to make it easier for us. So in Amazon has a service and set of tooling called CloudFormation. I'm actually going to demo that. Azure has their version, which is called Resource Manager. Terraform, which is the thing most people use. Terraform is a product from HashiCorp, and Terraform is really designed to allow you to describe in code in a set of software like constructs how to deploy to an environment, and then you could say, all right, deploy to Amazon, deploy to Azure, and it will deploy to both of those places with some level of success. But Terraform is a great product. So Terraform, Vagrant, Packer, there's a whole bunch of product sets that HashiCorp builds that you could use together. And Terraform is actually one of the most popular in that environment. I like CloudFormation. I'm going to actually jump into the idea of how we could use this in code, and I'll show I'm going to show a demo. CloudFormation is a service that Amazon provides that gives you a common language for describing and provisioning all the infrastructure resources in your cloud environment. So you can describe this in YAML, you can describe this in JSON, and you can say, hey, this is all the things I want in this big file, and you can give it to Amazon or give it to CloudFormation technically. And CloudFormation will go out and actually build all of that infrastructure for you. And if it fails, it'll tell you why, and it will let you update it. It's really great. I like CloudFormation because you can do things in stacks. I can say, here is a set of infrastructure that's related. Nginx web server, plus maybe some security around it, maybe a backend data store. It's all together. I need it all to work together. It's a stack. Deploy the stack. And then I can say, oh, destroy the stack, and I can do it all together. And you can manage those things as a group. So I'm going to do a demo for CloudFormation. Oh, and hopefully you can see it. My cloud is kind of spinning around. Yeah, my kid found that, told me how to use it for the talk. So there it is. All right, so let's take a look at it. This is CloudFormation in Amazon. And I have one thing running there. Don't worry about that. We'll talk about that in a minute. So I can create these stacks. And so I'm going to create a stack. And I'm going to give it new resources. And I'm going to upload a template. And I'm going to go get my template called Demo 1. Not a very exciting name, I know. I'm just going to name it Demo 1 so I don't lose it. I can give it parameters. I'll show the parameters in a minute. They're pretty interesting. We won't worry about any of this. Oh, actually, I'll tell you one thing we do. Well, I'll show that next one around. So I'll do a whole bunch of stuff, and I'll hit go. And it's going to start creating what was in that file. So let's go look at the file. This file, you know what? I'm going to switch over to here because because I think I can show it a little bit better if I pull it up here. All right. So just one thing, I'm going to be showing code. I mean, it's an infrastructure as code talk. I'm not expecting you to understand all this code, right? That's kind of not the point. I'll walk through it. I want you to get the feel for it, though, right? I mean, I want you to understand kind of what we're doing, and I'll kind of describe kind of what works, what doesn't, but you don't have to actually know how to read it. If you do, awesome, but you don't have to. This is in JSON. I mentioned that in CloudFormation, you can use JSON or YAML, whichever you prefer. And so this is a file that is describing deploying Nginx. And with Nginx, it's giving it a what's called a security group, which is really a host-based firewall. That's kind of what it is. So right here, I have this code right here that describes, that is describing the actual web server. So I've said, okay, oh, I can say when you start up, run this code. This code, all it does is install Nginx. It goes out and installs Nginx on itself. I can give it my size, so I can do T2 micro, which is tiny. I'll security group in a minute. I can get some information. Oh, image ID. So this is a base image, which would be Amazon Linux 2. So it's a version of Linux that Amazon provides and keeps up to date. Every month they roll out a new version. I actually haven't updated this file in a while, so this is probably a couple months old. But it's a resource ID. There is a specific virtual machine image, binary image out there, ready to be deployed. And I just said, hey, go and grab that one as my base deployment. Here's my security group description. This is basically a firewall. All it's saying is, hey, I want you to open up port 80 and port 443 to everybody. So it's a web server, right? So those are the two things. And that's basically what this code does. All right, so let's see how that code looks. Go back to our CloudFormation. So this is our code, which I was describing. I'll look at it in Designer. CloudFormation has this thing called the Designer, which allows you to visualize your JSON. I will tell you, I have never found anybody that uses this in production. Designer is, once you have a really good CloudFormation template, you've got hundreds of things. And so the boxes all get really confusing, and it's also clunky to work with. I've tried to use it to build something and it was a mess. Nobody really likes to use it, but it's great for a demo. We only have a couple things and you can show it. That's Designer. All right. Yeah, I don't want to use Designer anymore. All right, so I'll go back to my template. It took a little longer than expected. All right, it was demo one. As it was building, it was describing a whole bunch of events, and these are all the things that happened. You know, I'm starting to create something. I've created my security groups. I've created my server, which I've called my web page. You can look at all the resources, which is nice. I said something about parameters. I'll talk about that in a minute. And you also say output, and one of the outputs is an IP address. And there, it built a virtual machine that has Nginx with no interesting web page, but it worked. And it did it as a stack. So all these resources are created together. So if I wanted to delete them, I just got to click this button right here and they're all gone. All right. So that is a very simple, the simplest one I could think of. Here's a more complicated one. It's actually the same thing, but I'm going to put in some properties. Because remember, in the first one, I specifically said T2 micro. Here is the size of the virtual machine I want. But maybe you don't want to have the same size every time. You want to be able to pick it at deployment. Remember that whole idea of at deployment time, at runtime, I can make a decision on what size based off of my environment. So maybe that was okay for dev, but now I'm going to run this in deployment. So I can pick from a list. This is the list right here where you're seeing, hopefully you see it as it's caught up to me where I'm talking. This is the list and it's really big. And it's a list basically lets you help you pick the size of your architecture based off of what region you're in. So think about having to keep this up to date. It's really painful. As people are building their CloudFormation templates, I have met people that they're spending their time working inside of JSON in these CloudFormation templates. And it can be a lot of work to make the changes, which is not what you want. You want to be able to make changes as quickly as possible, but it can be difficult. But everything else here is exactly the same. So we'll deploy this. And you know what? I'm going to make a change. I actually do not want port 443 because I didn't set up SSL. So I'm going to delete that. All right. So I'm going to go over here to the stack. I'm going to create a new stack, whole new stack. I could update this one, but I'm just going to create a new one. I'll talk about updates in a second. Ooh, there's an error. See that at the top? Error, JSON not well formatted. So we can go back. All right. I did that on purpose. Look here, it's red in my ID. I'm using VS Code. I should have mentioned that at the beginning. I actually messed up my JSON. There's an array here, and I kind of took the back of the array off. Imagine if it wasn't, you know, what I got 221 lines. What if it was 1,000 lines? That might be really kind of a painful way to try and figure out what's going on. My point I'm trying to make with this is that your JSON or your YAML can be brittle, can be hard to maintain. And just doing it in this kind of code can be difficult. All right, I think it should work now because I changed it back. Let's do demo 2. Oh, actually, and it should have worked. Hit next. All right, demo 2. Now remember I created this, the parameters. I created 2 parameters so I can pick the size, T2 micro, and I can pick a key name, which is just a way to SSH into it. And so that's nice, I can be able to do that. Another thing I can do, which is on the next page, I can do estimated cost. I can click this, and it will actually tell me how much it would take to run this every month, for an entire month. So if I kept this running, continue simple. If I ran this, it would cost $8.50 to keep this running 24/7 for 30 days. It's nice to be able to see that. It's a very simple one. You could have a really complex system and it will tell you your gazillions of dollars you're going to spend. It can get pricey. All right, so I'm going to deploy this. It's just going to look like the same as the one before because it's nothing really any different. But I actually have 2 stacks here. So those are nice. So CloudFormation gives me some nice capabilities. I like the fact that I can do things in stacks. They can be a little daunting if I look at them as a whole. Let's look at a CloudFormation template for a LAMP stack. So it's Linux. It's got a Postgres database or MySQL database running. It's got some other tooling on it. Apache is running on here. This is, I'm sorry, I'm probably making it blurry, 411 lines for a single instance that's running a whole bunch of software. Look at this. Let me see if I can get to a really interesting. Ooh, this is a good one. So remember I said that you can actually say, hey, when you start a virtual machine, run all this code. This is the code that we're giving it with this quoted values and stuff. It's ugly. It's hard to use. Editing this can be a little confusing. But this is our LAMP stack. So you can see, and I just want you to get a feel, it's long and it can be hard to manage. Okay, but that's CloudFormation. I still love CloudFormation. It has some problems. There's another tool that I really like. It's called the Cloud Development Kit. And the Cloud Development Kit is an AWS product. And I should state, the Cloud Development Kit really is a competitor to Terraform. So if you're using Terraform, you could also use the AWS CDK. CDK, not SDK, right? CDK, Cloud Development Kit. The CDK is an AWS product that allows you to define your cloud resources using C# or Java or JavaScript, or Python or TypeScript. So what you can do is you can write Python code and it will interact with CloudFormation and build a CloudFormation template and deploy the CloudFormation template for you. That's pretty cool. Terraform is similar. Terraform, you're writing it in Terraform language, but Terraform will interact directly with AWS or Azure to build the infrastructure. It doesn't use the Azure Resource Manager or the CloudFormation to do that. It kind of tracks things on its own. The CDK allows you to do this inside of CloudFormation. So let's go look at that. I'm going to show you the code I was looking at before, you know, my Nginx server with a security group. But instead of a whole bunch of JSON, I actually have it in TypeScript. So let's go down to here. Ah, this is perfect. Remember how I was showing you the AMI, where it was, you know, this long number, AMI dash long number, and I said it was actually a couple months old. Boy, I want to redeploy this all the time. I want to keep it up to date. In the CDK, I can run this function that says, hey, go and get the latest version. Goes and queries Amazon real time to get the latest version of the Amazon AMI for Linux too. And then there's a couple other ones I could use. So it gets that latest AMI. Here's the code to build an instance right here. Use the Amazon Linux thing that I just found a few minutes ago. I have some user data, which is user data is the script you give it that says, go and run this the first time you build it. I have an instance type where I'm going to use T2 micro. Oh, and you know, a nice thing about this is because it's in TypeScript or Python and some other code, it's actually doing type validation. So I could have typed, you know, T20 micro, and you wouldn't know you messed that up until you try to give it to CloudFormation. But in here, the CDK will look at some of these things and go, oh, I only know T2 micro. I don't know what you're talking about, T20 micro. Here's my security group. I'm actually going to say, hey, here's my security group, but I want you to call a function. And I can actually write functions. It's TypeScript, it's Python. You have functions, you have environment variables, you have loops, you have variables, you have all that kind of stuff, libraries that you can attach to it. Here's my security group, and my security group is remember it's the firewall, right? So I could put these things in a loop. I could do an if statement. If production, or I should say this, if the dev environment, then allow SSH. Else, if production, don't allow SSH. I can have it smart, and I can do that with standard if-else statements that you normally would use. I'll tell you the other thing I'm doing in this code is I'm actually building, if in Amazon, I'm building a virtual private cloud. That is in CloudFormation, that is actually a lot of steps. But here, it's just this right here. That's it. It all is. And I'm actually building it with two subnets, a private subnet and a public subnet. I'm giving it my CIDR range. I'm telling it which availability zones to use. A lot of configuration I can put into this. But because CDK tries to make things easier for you, I can just make this one call, and now it says, okay, there's my virtual private cloud that you're going to build along with this. All right, let's deploy this. So inside of my terminal here, I'm going to do, make sure I'm in the right spot. Yep, all right, clear. All right, hopefully you guys can see this pretty well. CDK list. What CloudFormation stacks can I run right now? So it's going to give it. Oh, there's actually a few of them here. I'm going to run CDK deploy basic demo, which is what I just showed you, which is basically a virtual private cloud with Nginx and security groups or firewall. So I'm going to tell it to deploy. Remember, I went through the screens in CloudFormation and click, click, click. The CDK application is actually going to do that for me. Oh, this is cool. It's going to say, hey, you're going to make some changes to your identity access management roles, and you're actually going to change your security groups. Actually, you're going to create it. Are you okay with that? And this is great because if it sees security relevant changes, it can ask you, are you sure about this? Yes, I'm sure I want to do that. Okay, so now it's going to start deploying this CloudFormation template that I was describing. So let's go look at CloudFormation and see what's happening here. I should have one that says basic demo. There we are, basic demo. Okay, good. It works. The demo is working. I was saying earlier, I'm actually at the beach, and the internet went out today, like 2 hours before the talk. So it was a mad scramble. So I'm glad it's working right now. All right, so I look at my events. So just like, oh, I should say, here's my template. Now, this is the template that the CDK generated, not what I wrote. I wrote TypeScript code, and the CDK then went and created this code. It's actually a lot of code. I'm actually doing a lot with that small amount of TypeScript I wrote, so that's pretty cool. here's the resources it's creating. A lot more resources than what I created for, because I'm creating the virtual private cloud with internet access and router tables and subnets and profiles to be able to do certain things. And metadata, that's not a real thing. Internet gateway, like, so if you're familiar with AWS, this kind of stuff looks familiar. You've created these things by hand. I did it in that short amount of code. The CDK knew how to do that. So it's going to go deploy this stuff, and hopefully we have something running a little bit. We won't wait for it. That's pretty cool. I want to deploy something else. Yeah, let's deploy something a little bit harder. I'm going to deploy not just a simple Nginx server running on the internet, because that's not what we're going to do in production. We're actually going to deploy something like this in CDK. I'm going to write this in CDK. I'm actually going to deploy it for you. You're going to see it in a second. Just to describe, I'm going to walk through this. If you're not familiar with Amazon, hopefully I can explain enough so that it makes sense for at least for this talk. Before, I had one virtual machine running. That's not really good for resiliency. So I'm actually going to run multiple virtual machines, one in one availability zone, another in another availability zone. So 2 buildings in the same general area that Amazon has, I'm going to have 2 virtual machines running. So if one goes down, the other one is there. In order to do that, I'm going to have an elastic load balancer, which says, okay, give traffic to each of these. And if one goes down, oh, there's a problem, I'm going to tell the auto scaling system to go and spin another one up. So this is all stuff that's being managed. I'm going to do this inside a private network. I'm also going to have a public subnet with a NAT gateway installed. I'm going to be connected to the internet, and I'm going to set up a route table in my in a domain that I own. Route table saying, hey, I've got a new service at demo. The name of the domain. I'm not going to give it to you. It actually takes a few minutes to deploy all this stuff so that it actually works. But in the demo, it's actually pretty easy. So I'm going to run. Oh, let me show you the code. This is the code. It's actually not that much bigger than the first code. It's actually pretty much the same. I'm building a virtual private cloud like I described before. Here's my instance like I described before. I've got a little bit more data that I'm going to give the images. I'm going to create an auto scaling group there. Ooh, my mouse went crazy. Here's my 8 lines for my auto scaling group. Here's my 4 lines for a load balancer. And if I wanted to be smart, I could actually do it in 1 line. Here's my Route 53 change. So I'm actually going to change my domain and do all this stuff. It'll deploy, but you won't be able to route to it. It'll deploy the whole thing within a few minutes. Oh, I'm going to list it on port 80. Anyways, this is all the code I'm writing in TypeScript to deploy what I just showed you. So I'm going to deploy it, and then we'll go take a look. I wrote a script so I didn't have to type it. Here's what I'm actually deploying. I'm not just deploying this in one location on the East Coast. I'm deploying this entire stack 2 places. I'm also deploying it in California. And because I'm doing it in 2 places in California, in order to get it in 2 locations, I had to add 9 characters to my code. That was it. I was just actually having a loop that says, do it in the East Coast and do it in the West Coast. And the Route 53 will actually route between the 2 locations depending on where you are hitting the web server. I wrote 110 lines of TypeScript that's being deployed right now. CDK generated 750 lines in CloudFormation. And if I was going to do this in both locations, in CloudFormation, if I were to write the CloudFormation, I would probably use the same one, but I would have to have a whole lot of weird stuff with parameters in order to deploy it in the 2 locations. And I can do it all with just 110 lines of code that I showed you, and which is this code, and it's actually not a lot of lines, to be honest with you. It should be deploying right now. It's deploying on the East Coast. It's probably not deploying on the West Coast yet because it's going to deploy East Coast first yet. So it's going to take a few more minutes, more than I'm going to make you sit and wait during a demo, because that would be boring. But you can get the idea of what it's deploying. One thing let's look at the template that was created. This is what the CloudFormation template looks like. You're not going to read it, but just get a feel for it. Imagine having to manage this. And it's really only one web server. So if you have 50 web servers or 100 web servers, this could be a lot of work inside of your stack. I like CDK, the CloudFormation Development Kit. I like it for a number of reasons. One of the big ones is because I'm writing in TypeScript and Python, I get the full use of the coding structure and the coding language. If I write it in the Python, and if you've ever done any Python development with Amazon, you've used Bado 3, which is Amazon's software development kit that makes it super easy to interact with Amazon. You could build that right into your CloudFormation development kit. So I've done the deployments where I said, before I deploy something, I'm going to go and check my current environment and get some parameters, or go and scan and find the names of things, and that determines how I deploy it. And I can use Bado 3 to do that. It's really nice. The other thing is that I get to use the CloudFormation. So I get these full stacks that are being deployed, and I can stop them and start them and do that outside of CDK, but I can do the deployments inside of CDK. The other nice thing is I get to make use of code scanners or commenting and all that kind of stuff that you would normally do with TypeScript or Java or Python. I can integrate that inside this software, or the CloudFormation development kit. All right, just to wrap up, and then I have some time for questions. When you're thinking about moving from your artisan infrastructure deployments to software as a code, infrastructure as code, your infrastructure team probably does not have the skills to do it. They're probably not developers. I mean, if they were great developers, they would probably already be developers. Your development team is not familiar with information security or anything like that. Probably, maybe. I mean, there's a couple. There's probably a couple if you're a big enough team, or there's somebody that's really interested in building the two. I usually say find somebody or a couple people that can be great at both or good at both, and use them as a nucleus, and then start training people to cross-train. Or build in your environment with your folks a way to say, hey, developers come in that know Python, the infrastructure team is going to describe what you're going to need, and you're going to be able to say, okay, here's how you would actually deploy that, and write the code and build all the testing and all that kind of stuff with it. Your blueprints, like the CDK, is going to take a long time to build it the first time. A little less time to build it the next project you have, but that learning curve can be a little steeper, but that's okay. As we described in the very beginning, if you're building that weird looking red hand, you're going to spend a lot of time figuring exactly how that hand's going to look, but you can build 1,000 hands just by pushing a button. And so that's a great way of doing that with this infrastructure as code. You can also build code in modules. So especially with CDK, you could write a Python library that says, this is how I deploy, web servers in my environment. And so the marketing team that says, I'm going to deploy the marketing web server, I can go and pull that library like I would in normal code. Another thing that you can do from a security standpoint, which I really haven't talked about security too much, but the most exciting thing to me is how I can implement security inside of this practice. Right now, in most organizations, you probably have a policy that states, this is our security deployment, right? This is how I deploy, virtual machines securely. Maybe it's not written down, maybe it's in someone's head. I don't know how that works. But you have to rely on people to do the right thing to deployment, and people are fallible and they'll mess up. You could bake in and codify your security requirements inside of a CDK. You have the ability in CDK to say, do not deploy unless it meets all of my security checks. You can do that kind of stuff inside of these environments. So it's really nice. The other thing I would suggest as you're building these, when you think about how to bake security in the beginning, your blueprint's going to take longer at first. That's okay. You're going to adapt your design over and over again. You're going to have an infrastructure in place that you built by hand. And then if you were to build that same infrastructure or for the same purpose, and you did that in infrastructure as code, it's going to look different because you're going to adapt your design of your infrastructure to meet infrastructure as code. That's just kind of something you're going to be able to do. All right. And with that, that is the end of the talk. I do think I have a couple questions, so give me a second. I'm going to look at the question. There's a couple in here. So the first one, so Mark who left, we had made a couple notes. He said he couldn't see my screen, but one thing he was saying is cattle, not pets. That's definitely I think an Amazon ism for how to treat your infrastructure. Back in the day, you had your servers and you named them things, like Zeus was like the domain controller or whatever, and you had all these other servers. But in infrastructure as code, I don't care so much about individual servers. They could be destroyed and rebuilt at a moment's notice. So I don't care about individuals. I care about more of their goal and how they work together. So yeah, that's absolutely right. And with infrastructure as code, these kind of concepts, the individual servers don't mean as much as the blueprint for them. All right, another question was, can you use Kali image provision in AWS? Ooh, yes. Actually, if you go into Amazon, and I'm sure Azure and Google and Alibaba and all those folks, if you go to their marketplace, you can go and say, click Kali and build it in Amazon. Yeah, you can absolutely do that. You can also run, maybe not Kali, but Kali tools and Docker in a lot of different ways. But if you were to build an Amazon or Azure infrastructure, and you were going to have a pen test team, let's say, or maybe your forensics team or whatever, they'll probably have images set up and ready to go, and you can just say, hey, go and deploy into this environment to do my evaluation. So yeah, you would have those, you have them set up. So code scanners, so there's actually, Amazon has come out with a new code scanner for CloudFormation, and it's pretty neat. I'm not going to remember the name of it off the top of my head because I just read about it this week. But this code scanner will look at your CloudFormation template. There's something called CF init, which would scan it and look to see if it was structured properly, and those are nice. You wouldn't have to do that with CDK because CDK does that kind of scanning for you, and it has defined how you're supposed to build certain things, so you wouldn't have that kind of problem. But there is actually a new Amazon tool that has come out that will allow you to scan your CloudFormation template, and you provided a set of directives for what you want from a security standpoint. Like you can say no port 22 for SSH, and it will scan that CloudFormation template, and it will alert if there's a problem. And then your code, your pipeline can look at that and say, okay, I'm not going to deploy because it doesn't meet my requirements. In CloudFormation development kit, you could do the same thing. You could actually set up libraries that would then scan the CloudFormation code you're building and can reject based off of certain aspects, but you have to code all that. So you could do that. And beyond that, there's a couple other tooling for CloudFormation, but the new one that Amazon just released, and I'm sorry, I can't remember the name of it. If somebody knows, put it in chat. But it's actually supposed to be really good. But they're examples. They only have a couple examples, so it's really, really new. Oh, the other thing you can do, this is what I do in our team. We require documentation, and then we actually will extract documentation and build web pages every time we push to our Git server. And so our GitLab server will get it. It will actually pull out all the documentation, and we'll fail it if there's no documentation inside the code itself. So your CloudFormation development kit, that TypeScript code or Python code, you could self-document what your infrastructure looks like inside of there with comments, extract it as a web page. It's kind of really neat. Okay, another question. So CDK is specific to Amazon. I do like Terraform. I will be honest with you. I haven't used it as much as I've used CDK. I was running on an Amazon team or as Amazon infrastructure, and CDK came out in beta, and I said, "Ooh, that's fun. Let me play with it." And because I'm a Python developer, I really like the idea I could use Python for it. Terraform is great for certain things. Terraform is definitely great if you're going to be multi-cloud. Terraform is also great if you have a whole bunch of Terraform people. Right? I mean, you got to use the tools that people are familiar with. But Terraform does not allow you to use CloudFormation, so you don't have that stack mentality. Terraform also does not allow you to integrate as easily things like the Amazon software development kit. There are ways to do it, but it's not as seamless. So there's pros and cons. I would encourage you to check out both and pick the one that feels better for your team. I showed CDK because it's kind of newer. Most people aren't using it, and I think it's really neat, but you kind of have to use what's right for your team. So hopefully it helps. All right, well, I think that's it for the questions. So I appreciate your time. Thank you very much. And I hope you have a great time building infrastructure as code.